Imagine a future where humans are not just an Earthbound species, but an interplanetary one. Picture a world where our children or grandchildren may not just dream of becoming astronauts, but interstellar travelers. A world where the phrase worldly experience takes on a whole new meaning. Space travel is no longer the stuff of science fiction. We've set foot on the moon, we've sent rovers to Mars, and we've peered into the farthest corners of our universe with our telescopes. But for all our achievements, we are still tethered to our home planet. Our current technology allows us to explore our solar system, but journeying beyond it remains a far-off dream. The limitations of our current technology are twofold. First, there's the problem of speed. The vastness of space is so immense that even at the speed of light, a speed we are currently incapable of reaching, it would take us 4 years to reach the nearest star, Proxima Centauri. And that's just the closest star. The distances between galaxies are even more mind-boggling. Second, there's the issue of fuel. Traditional rockets operate on chemical propulsion, which is highly inefficient for long-distance space travel. Not only are these fuels heavy and expensive, but they also run out quickly, limiting the range and duration of space missions. But what if there was another way? What if we could overcome these barriers and truly become a spacefaring species? Enter ion propulsion, a technology that may just hold the key to unlocking the cosmos. Ion propulsion is not a new concept. In fact, it's been around for decades. But recent advancements have brought it into the spotlight as a potential solution for long-distance space travel. By using electrically charged particles for propulsion, ion drives can reach much higher speeds than traditional rockets, and with much less fuel. So, I ask you, could ion propulsion be our ticket to the stars? As we delve deeper into this topic, let's explore this tantalizing possibility and what it could mean for our future. Strap in, let's journey into the unknown. Ion propulsion might sound like something out of a science fiction movie, but it's actually a very real and promising technology. Imagine a pool table for a moment. When you hit the cue ball, it transfers its momentum to the target ball, sending it off across the table. This is a simple analogy for how conventional rocket engines work. They burn fuel to create a forceful push, propelling the spacecraft forward. But ion propulsion? That's a whole different game. Ion propulsion is more like a marathon runner rather than a sprinter. It doesn't rely on raw power, but rather on steady continuous force over a long period of time. It's like gently and persistently nudging the cue ball along bit by bit. Here's how it works. An ion thruster takes a gas, usually xenon, and gives the atoms an electric charge, or ionizes them. These now ionized atoms are then accelerated through an electric field, creating a stream of ions rushing out of the back of the engine. This stream is what provides the thrust, pushing the spacecraft forward. The key here is that ion thrusters are incredibly efficient. They use a tiny amount of fuel and can run for a very long time, building up speed gradually. While a traditional rocket might be faster off the mark, an ion thruster can eventually reach much higher speeds because it can keep accelerating for months or even years. It's like the story of the tortoise and the hare. The hare, like a conventional rocket, starts off quickly but soon runs out of energy. The tortoise, on the other hand, moves slowly but steadily, and in the end, it's the tortoise that wins the race. So that's ion propulsion in a nutshell, but what does it mean for the future of space travel? Ion propulsion isn't just a fascinating concept, it's a technology with incredible potential. This might seem like something straight out of science fiction, but it's a reality that's being developed right now, with the ability to take us to corners of the universe we've only dreamt about. Let's start with efficiency. Traditional chemical propulsion systems like those used in the rockets we're familiar with can produce a lot of thrust, but they burn through their fuel quickly. Ion propulsion, on the other hand, is like the tortoise in the fabled race. It starts off slow, but over time, it can reach much higher speeds because it uses its fuel incredibly efficiently. This is because it works by electrically charging or ionizing atoms and then expelling them from the back of the spacecraft. This process provides a continuous, albeit small force that propels the spacecraft forward. And it's this slow and steady approach that makes ion propulsion perfect for long-distance space travel. Imagine a car that could travel across continents on a single tank of gas. That's the kind of efficiency we're talking about. It's a system that could keep a spacecraft moving for years, or even decades, making the vast distances of space much more manageable. Compared to current propulsion systems, ion propulsion is still in its infancy, but the potential is enormous. NASA's Dawn spacecraft, for instance, has already shown us what's possible. Using ion propulsion, Dawn visited Vesta and Ceres, two of the largest objects in the asteroid belt, on a single mission. This kind of multi-destination capability is simply not possible with traditional propulsion systems. With all these advantages, it's clear that ion propulsion could revolutionize space travel. But what does this mean for us, as a species? It opens up a universe of possibilities, literally. From becoming an interplanetary species to reaching our nearest galaxy light years away, the potential is as boundless as the cosmos itself. Ion propulsion could be the key to unlocking a future where humans are an interplanetary species. This statement holds profound implications for the future of human space travel. But what does it really mean to become an interplanetary species? Well, imagine a future where Earth is not our only home. Picture colonies thriving on Mars or the icy moons of Jupiter, where humans have adapted to survive and prosper in environments starkly different from our own. This is the potential future that ion propulsion could make possible. Ion propulsion systems are incredibly efficient, capable of reaching speeds that traditional chemical rockets can only dream of. This makes them ideal for long-distance space travel, such as missions to Mars, Jupiter's moons, or even farther into the cosmos. Colonizing other planets might seem like a concept straight out of science fiction, but the reality could be closer than you think. Scientists across the globe are already working on technologies that could enable us to live on other planets, from habitats to suit our biological needs, to systems that could extract water from the Martian soil. Becoming an interplanetary species would not only be a colossal achievement for humanity, but it could also help ensure our survival. As the saying goes, don't put all your eggs in one basket. In the face of potential global catastrophes, having a presence on multiple planets could be our insurance policy against extinction. But beyond survival, the exploration and colonization of other planets could open up new frontiers of knowledge and discovery. We could uncover secrets of the universe, answer profound questions about our existence, and perhaps even encounter other forms of life. The journey to becoming an interplanetary species won't be easy. It will require immense technological innovation, international cooperation, and a spirit of exploration that pushes the boundaries of what we believe is possible. But if we can harness the power of ion propulsion and continue to dream big, that future could be within our reach. Ion propulsion could truly be our ticket to the stars, ushering in a new era of human exploration and discovery. So, where do we go from here? At this moment, ion propulsion is not just a concept confined to the pages of science fiction novels or the scenes of Hollywood blockbusters. It's a reality we're actively exploring and developing. Yet, like any frontier, it comes with its own set of challenges and hurdles to overcome. Ion propulsion is a new technology that uses a stream of ions, charged atomic particles, to create thrust and propel a spacecraft. This type of propulsion is highly efficient, using less fuel than traditional propulsion systems, and allowing for longer, more sustainable missions. However, the technology is still in its infancy, and there's a long road ahead before we see ion propulsion engines powering our journeys to the furthest reaches of the cosmos. The main challenge lies in scaling up the technology. Current ion propulsion systems can generate only a small amount of thrust, suitable for unmanned missions in space, but not enough to carry humans to other planets or stars. Researchers are working tirelessly to develop more powerful ion engines that could potentially carry larger payloads and even human crews. Another hurdle is the longevity of the propulsion system. Although ion propulsion is incredibly fuel efficient, the system itself can degrade over time due to the high-energy ions, potentially limiting the lifespan of the spacecraft. Scientists are investigating materials and technologies to increase the durability of these systems. Despite these challenges, progress is being made every day. Laboratories and research facilities around the world are dedicated to advancing ion propulsion technology. Each new discovery, each successful test, brings us one step closer to realizing the dream of becoming an interstellar species. As we stand on the precipice of this new era in space exploration, we can't help but look up at the night sky with a renewed sense of wonder and anticipation. The future of space travel is incredibly exciting, and with ion propulsion it seems that the stars are truly within our reach.